Good morning. Good morning. If you're online, please indicate that you're online. If you're online, please indicate that you are online. If you're online, please indicate. And let's keep sharing the group link. Okay, our outline for today's class is going to be, we'll look at a little on dimensional analysis. Dimensional analysis. Then we'll also look at Newton's laws of motion. Then when we are done with this, we're going to kinematics, linear kinematics. Linear kinematics. And all that. Okay. Then after this, we'll look at past questions. Past questions. Past questions. All right. So this is going to be our outline for today. I want to welcome you all to this morning's class. And most of you are not awake by now, but I believe that when you come online, you can always find this video. All right. On our YouTube channel. You can always access the video on our YouTube channel. All right. So please, if you're online, indicate your presence that you're online and share the group link. Share the link rather. Share the link to your WhatsApp platforms. If you're online, please share the link. Please share. Let's keep on sharing the link. 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 All right, so guys, we're going to start now. I want to believe that we all know what is dimension analysis of physical quantity, right? I want to believe that we all know what is dimensional analysis. Okay, we'll start with the first outline. I will talk briefly on this because we have done this several times. I believe that most of you have the fundamental knowledge already. Okay, so when you hear the word dimension of physical quantity, it is the expression of that quantity. It is the expression of physical quantity. Okay, in terms of fundamental quantities of mass, length, and time, it is the expression of physical quantities in terms of fundamental quantities of mass, length, and time. That's called dimension. Dimension in physics simply means the expression of physical quantities in terms of mass, length, and time. All right. You know, we have two types of quantities. Quantities in physics are grouped into two. We have what we call the fundamental, right? Fundamental quantities. And we have what we call the derived quantities, right? Quantities. Fundamental quantities, we call them the basic quantities in physics. They are the basic, they are self-defined. They don't depend on any other quantities to define them. All right, and a good example of fundamental, the metric system, which are the mass in kilogram, length, in meter, then time in seconds. These are the three basic fundamental quantities. We have other ones that also follows. We have the electric current, okay. We have amount of moles, etc, and so many other fundamental. But the three basic are just the mass, length, and what, and time. So the expression of physical quantities in terms of their fundamental quantities of mass, length, and time is simply referred to as what? Dimension. Dimension of physical quantities. All right. Then after this, I will explain what is dimensional analysis. Then the derived quantities. These are quantities that depends on the fundamental quantities. All right. They are not self-dependent. They depend on the fundamental to define them. They cannot be defined by themselves. Okay, so they are not the basic. So they are always gotten either through multiplication or division of two or more fundamental quantities. A good example of this, we have our speed, we have our velocity, we have our density, we have our force. Speed is distance over time, velocity is displacement over time, density is mass over volume, force is mass times acceleration, work done is force times displacement, power is work done divided by time. Any quantity gotten either by division or multiplication of two or more fundamental quantities are called the derived quantities. They are not self-dependent, they depend on the fundamentals to define them, right? Now, I'm not going into it, I just want to give a breakdown of what fundamentals are. So when you hear the word dimension, simply means the expression of physical quantities in terms of their fundamentals, which are mass, length, and what, and time, is referred to as what? Dimension. And the dimension of mass is simply capital M. The dimension of mass is measured in kilogram, is capital M. Dimension of length in meter is capital L. Dimension of time in seconds is capital T. What this implies is that any quantity in physics, any physical quantities in physics, physical quantities simply means fundamentals and derive, which is what I just did here. Any physical quantities in physics that is measured in kilogram must take the dimension of capital M. Any quantities in physics measured in meter must take what? The dimension of capital L. Any quantity measured in seconds must take the dimension of what? Capital T. For meter, for instance, quantities like radius of a cycle, diameter of a cycle, height, distance, displacement, okay, all of these measurements are in meters, right? Their units are in meters, so their dimension is capital letter L. Then time, any quantity measured in time, like period of oscillation, okay, which is measured in seconds, must take a dimension of capital what? T. We have other ones, fundamental quantities like temperature, right? Temperature. And all that. Temperature can either be represented as temperature. The fundamental quantities of temperature is mostly we use theta or we use K to represent temperature. Alright? Then electric current, which is measured in amp, we use the units to represent their dimension, capital A. Alright? But the basic three fundamental quantities are the metric system of measurements, which are the mass, length, and what? And time. I hope you are following. So please, if you're online, please share this link to other people. Let them join us this morning. Please, if you're online, please share the link to other people. Let them join. Let them join. Okay, then what then is dimensional analysis? Dimensional analysis is a method of using the dimensions. Is a method of using the dimensions of physical quantities to check the correctness of equation or to derive relationships between physical quantities. I repeat again, dimensional analysis is the method of using the dimensions, right? Like the mass, length, and time of physical quantities to check the correctness of equation or to derive the relationship between physical quantities, right? It is the method of using the dimensions of these quantities to check the correctness and the relationship. But for Imo State University exam, please take note. If you have to define the dimension of physical quantities, this refers to the way it is connected. This refers to the way it is connected, associated, or related to the fundamental quantities of mass, length, and work and time. This refers to the way it is connected, associated, or related to the fundamental quantities of mass, length, and time, right? And we say that the dimension of mass is in capital letter M. That of what? Length is what? Capital letter L. That of time is what? Capital letter T. Now let's move further to we'll solve some problems here. Then we proceed further to all right. Let's look at this. If we have to find the dimension of the following, dimension of the following, the first one, let me repeat what we have: mass. Number 2, length. Number 3, time. Number 4, okay, distance. Number 5, velocity. Number 6, let's say acceleration. Acceleration. Number 7, force. Number 8, work done. Number 9, power. Number 10, let's look at stress for material. Number 11, look at strain. Number 12, Young's modulus. Number 13, pressure, etc. All right. All of this we'll look at today. Then after we are done with this basic, we'll go into complex examples, right? Okay. Already we know solution for the first one. The first one says the dimension of mass. Mass we know is measured in kilogram. The dimension is simply what? Capital letter what? M. There are two ways we can get dimension of physical quantities. The other way we take note of their units. Then we say that any measurement in kilogram must have what? The dimension of capital letter what? M, right? The number 2 says length. Length is in meter. Dimension is capital letter L. Number 3 says time. Time is in seconds. Dimension of capital letter what? T. Okay, then the next one is IV, which is our distance, right? Distance formula says, okay, distance rather is measured in meter, right? So dimension is what? Dimension for distance is capital letter L because it is measured in meter. But I said any quantities measured in meter must have a dimension of capital letter L, right? Like we have radius and so on and so forth. Then the next one, number 5, is velocity. From here, we can get the dimension of this from the units. But because I'm teaching, let me show you how we can also derive this. Velocity is given as displacement over time, right? Displacement we know is in meter. Time we know is in seconds, right? So dimension of velocity becomes what? Becomes capital letter L. Okay, let me come down here. Becomes our meter is capital letter L. Then second is capital letter T. By the time we move this upward, law of indices, if I have 1 divided by T, this is same as T goes to the power of -1, right? So here we have L times. So if we have this L divided by T, this is same as L times 1 over T, right? So by the time we restructure this 1 over T, 1 over T is same as what? LT minus 1. And that will give us what here? LT plus 1. So the final answer here is simply LT minus 1. Okay. I also said that we can get the dimension from the units, right? From the units. Using the unit, for instance, for the unit of velocity we know is meter per what? Second. Any quantity measured in meter must take dimension of capital letter L, right? Then second is what? Capital letter T. So we have -1, right? Are you seeing it now? So from their units, we can also get their various what dimension. Now, we have done this. The next one we'll look at now is, we have done velocity. Okay, let me just show us another one, which is called speed. Speed is also given as distance over what? Time. The dimension of the unit of distance is in meter, time is in seconds. That will give us dimension of m meter is capital L, that of second is capital T. This will also give us LT minus 1. What does that imply? That velocity and speed, they have the same dimension, and they have the same SI units. But although they are not the same, all right? Velocity itself is a vector quantity because we cannot fully describe this without talking about direction, right? Then speed is a scalar what? Quantity. Okay. So the next one I want us to look at is acceleration. Number 6. Acceleration is simply velocity over time. Over time. Our velocity here, the dimension of velocity we have already solved is LT minus 1, right? LT minus 1. Then time is capital letter T. Don't forget. So acceleration then becomes what? By the time we move this up, this will always come up. This will give us what? LT minus 1. This is for the minus 1. Then when you move this thing up, it becomes times what? T minus 1. So acceleration becomes LT minus 1 plus minus 1 is what? It's minus 2. So this is the dimension of acceleration. Or we can also get this from the unit of acceleration. Acceleration says what? Meter per what? Second squared. From the units. Meter is capital letter L. Seconds is capital letter T. Then minus 2. Right? You can also get that from the unit. Please, if you are awake, if you are online, do me a favor, share the link. Share the link. Share the link. Let's reach out to others. Okay, please share the link. 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 Please, if you have shared the link, please. We have a lot to solve. This is just a building class. Most of you are already familiar with this. By the time we start solving some questions, you understand why we have to start from these fundamental questions. Okay? By the time we start solving from there, you will now understand better. Now, let's finish up. Hope I can clean this side, right? Okay. The next is force, right? Force is mass times acceleration. Force is mass times acceleration. So that means our force, the dimension of force, mass is in kilogram. Don't forget. Acceleration is in meter per second squared, right? You know, I say we can also get that from the unit. Or I can just say mass is capital letter M. Then already we have already gotten acceleration before, right? As LT minus 1, minus 2 rather. LT minus 2. But let's get it from the units. So force will now give us what? Kilogram is capital letter N times our meter is capital letter L, then T raised power what? Minus 2. So force is simply MLT minus 2. So the unit of this force can also be a kilogram meter per second squared, or 1 kilogram meter per second squared is equals to 1 Newton. 1 Newton. So the whole of this can also be called what? 1. Now let's move on to the next one. We have done work. We have done force. Let's look at work. Work done. For that of work is force times displacement. Work is force times displacement. So our work done becomes what? Our force dimension already, we have already gotten force as MLT minus 1. So we have MLT minus 2 rather. MLT minus 2. Multiply with displacement is measured in what? In meter. Don't forget, in meter. And the dimension of displacement is capital letter L. So here we have capital letter L. So work done will then give us, we're going to multiply the common factors here based on the law of indices. If we have A raised power B times A raised power C, the law says what? I will pick a common base, right, and add up the power, which is B plus what? C. If you look at it, we have L and we have L, and their power is what? 1, 1. So that means I will pick one of the letter L and add up the power. Okay? Okay, using the law of what? Indices. But the first one is that I have to bring out what first? M. Okay, then L times L will give us what? L squared. Then T raised power minus 2. T raised power what? Minus 2. So this is the dimension of work, ml squared T minus 2. Alright, so the next one is for power. Power is simply work done over time. Work done over time. Already we have solved the dimension of work as m L squared T minus 2. This is for work done, ml squared T minus 2, right? Then we're going to divide this by capital letter T. By the time we bring this other T up, the power becomes minus 1. So we have minus 2 minus 1, right? So my power dimension becomes what? ml squared T ml squared T minus 2 times T minus 1. So power becomes ml squared T minus 3. ml squared T minus 3. Because minus 2 minus 1 is minus 3. That is the dimension for power. So please, if you are following, indicate that you are following. Indicate that you are following. If you are following, please indicate that you are following. Okay. I've cleaned some other ones, so let's just solve for other ones, okay? I think we have seen power. Let's look at density. Density is mass over volume. Mass is in kilogram, volume is in meter cube. Volume is in meter cube. So that means the dimension of density, kilogram is capital letter M, meter is capital letter L, then we have cube, right? So by the time we move this upward, this becomes what? This becomes capital letter M, L minus 3. The next one we'll look at the stress. Stress of a material, okay? Stress is simply force over area. Stress and pressure have the same dimension because they have the same definition. When you do the word stress, it means pressure. When you apply pressure on a material, it simply means what? Stress, right? On the material. So stress. Force, we have only defined the dimension of force as ml T minus 2, ml T minus 2 divided by, okay, let's define this first. The unit of force we know is kilogram meter per second squared, right? Unit of area is meter squared. Area is meter squared. So stress of the material becomes, our dimension for kilogram is capital letter M, meter is capital letter L, then we have T to the power of minus 2 divided by, dimension for meter is L squared. So that means our stress, which is also known as what? Our pressure, is equals to what? From here, one of these L, we cancel one of this L. If one L cancel one L from here, we are left with what here? mt minus 2 divided by what? L. So when you move this L up, what do we have? We're going to have L minus 1, T minus 2. Now, are you seeing the order of arrangement? The order of arrangement of your fundamental, of your dimension must be in this order. MLT must be in this order. Please take notes. Very, very important. It must be in this order of arrangement. All right, so let's proceed. Let's proceed further. The next one is to find what we call strain. Strain is extension over length. Strain extension is in meter. Length is also in meter. So our strain has no dimension because dimension for capital letter M, dimension for M rather, M, right? M over M. Or I can just cancel that M from here. That will give us 1. But let's see express it. Okay, M is letter L over what? Letter L. The result becomes what? 1. So that means strain has no dimension. Then Young's modulus, which is stress, tensile stress over what? Strain. Tensile stress over strain. Don't forget that we have already defined our stress as force over area, right? That's our stress. Then divided by what? Extension over length. Is that clear? Okay. So what do we say will happen here? We have force over what? Area times length over what? Extension. This will cancel out this. Already we have seen that strain has no dimension, is 1. So I can say that the dimension of Young's modulus is same as that of what? Pressure or stress. Because if strain has no dimension, this is like saying stress over 1, right? Stress over 1. So that means the dimension of stress is same as that of what? Young's modulus. So Young's modulus will then be our force. We have already done that before, right? Okay. Our force, which is kilogram meter per second squared. Again, area is what? Is meter squared. And that will give us what here? Capital letter M, LT minus 2 divided by what? L squared. And that will give us M, L minus 1, T minus 2. Don't forget. Okay, so this is the dimension of what? Of Young's modulus. This is same as the dimension of what? Of stress. Also same as what? Dimension of what? Pressure. So Young modulus, pressure, and stress have the same dimension. Now let's solve some problems from your textbook. Please, if you are following, please indicate that you are following. Good morning, everyone. Those who just joined us, you are welcome. Okay, let's solve a problem. One of your past question now. Equation here says list two applications of dimensional analysis. Two applications of dimensional analysis. Okay, number one is that it is used in determining the homogeneity of any physical relation. One, it is used to determine the homogeneity of any physical relation. Number two is that it is used in deriving and converting units, right? Number three is it is used to determine the correctness of an equation. Determine the correctness of an equation, right? When we started this class, I was able to define the word dimensional what analysis, right? Or dimension rather. Let me go back to the notes for proper understanding. I say that dimension is defined, right? As excuse me, let me get the definition. Is a method used in expressing physical quantities in terms of what? Fundamental quantities to check the validity of equation or to derive the relations between physical quantities, right? Now, when I say give two applications, you can just start by starting with it is used to check the validity of an equation. Number two, to check the correctness of an equation. They are almost the same. Number three is that it is used to determine the homogeneity of any physical relation. All right. Number four, it is used in deriving formulas. It is used in converting units. It is used in deriving units. Many of them. But if they say two, just bring out among any of these I've listed as two, two application or two uses. They might use the word applications. They are all the same. Okay, so let's solve one of your past question here. We have seen the first question, right? List two applications of dimensional analysis. The next question here says that if the number of moles of a gas occupied in a cylinder, excuse me, if the number of moles of a gas occupied in a cylinder is directly proportional to pressure and volume and inversely proportional to temperature, determine the dimension. Okay, if the number of moles of a gas, select and represent number of what? Number of moles, right? Of a gas. And we are told that is directly proportional to pressure and volume. The first one is a number of mole is what? That proportional to what? To pressure. This is a direct relationship. Direct means as one factor is increasing, the other must increase. That means both of them are positive to each other. So if the number of mole is directly proportional to pressure, that is the first statement that was given. And volume, the number of mole is also what? Directly proportional to what? To volume. That is the second equation that was given. And we are told that an inversely proportional to temperature. Number of mole is inversely proportional to what? Temperature. 1 over what? T. This is equation what? Yeah? Equation 3. Then we have to find the dimension of the number of moles. So let's combine this. All we need to do is to combine the three equations, right? Combine the number of mole is what? Proportional to P. I'll multiply all of this together. P times V times 1 over T. That will give us PV divided by what? T. Don't forget, I multiply this, and this. Because these three equations has a common factor, which is n, right? Let's call this equation what? 4. Now the next is to remove this sign of proportionality. In mathematics, if I'm to take off this sign, I have to introduce a constant, right? And also an equal sign. That means my number of mole becomes what? K PV divided by what? T. Where K represents what? a constant. And you have to note that I didn't give this foundation. You have to know that every constant value have a dimension of 1. Every constant value must take the dimension of 1. For example, if I have 2 pi, the dimension of 2 pi is 1. Because why? 2 pi is a constant. Or if I have pi, pi is 1. If I have k, and k is defined as constant, like rate constant, gas constant, okay? The dimension must be equal to what? To 1. So dimension of this k, by the time we start expressing, must be equal to 1. Now, we have to find a dimension of each of these, right? Dimension of each of these. P there represents pressure. Y, V represents what? Volume. Now let's go. The next is to find the dimension of each. Dimension of pressure. Already we have defined pressure as force over what? Area. Because this is an exam, we have to start. Don't assume that you know it. You just have to bring out the dimension itself. You can start by bringing out here we have kilogram, right? Meter per second squared divided by area is what? Meter squared. So pressure becomes kilogram is capital letter N, all right? Our meter is capital letter L. Then we have T minus 2 divided by L squared. So pressure becomes capital letter M. One of these, right? We cancel from here. We are left with what? L minus 1. Because if I have 1 L here, when this comes up, becomes a minus 1. Then T minus 2. All right? So let's move on. Then the next is to find the dimension of volume. Because V represents volume, right? Volume is a meter cube. So dimension of volume is what? L raised power 3. Right? L raised power 3, L cube. Alright, so let's look at the dimension of temperature. Dimension of temperature. I told you guys that we can either represent it as theta or as what? Kelvin. Or as Kelvin. But most of the time we use theta. So we use theta to express it. The next is to find the dimension of our constant, right? Dimension of constant. Of the constant K. Constant K. The result is 1. Every constant must have dimension of what? Of 1. So let's impute our value. Then recall that N is equals to KPV. KPV divided by what? T. So N, number of moles, dimension for constant K is 1 already, times our pressure. Our pressure is mL minus 1 T minus 2. Okay. Kilogram meter per second squared. I want to be sure of our value. So we can proceed from here. Okay. Okay, we are correct. Volume is meter cube, which is L cube. Temperature is okay. Let's move on. Then multiply with volume, which is what? L cube. All divided by our temperature is use theta. So number becomes what? Here we have minus 1. 1 times any factor is that factor, right? Okay, but our emphasis will not be on this. Here we have the power of L here is what? Is minus 1. Multiplying L cube, right? So I will take the common base and add up the power. Don't forget the law of indices. Since their bases are the same. So I'll pick one of these bases, right? So let's move on. This will give us capital letter N. Okay. L minus 1 plus 3 will give us 2. Minus 1 plus 3 will give us 2. Then T raised by what? Minus 2, right? Alright, so divided by what here? Theta. By the time we move this up, this becomes M L squared T minus 2 theta minus 1. Final answer. When you move this theta up, it becomes minus 1. So ML squared T raised by minus 2 theta raised by minus 1. Please, if you understand that, indicate in the comment section that you understand it so we can proceed from there. If you understand what we just did now, please indicate that you understand. If you are following, awesome. Someone said, I understand. Please ensure you share. Keep on sharing. Let's share to other people to join. Let's look at another question. Stay from the past question. Stay from the past question. Okay, from your textbook, we're going to solve a problem now. Question says that, question number 1, from Newton's law of gravitation, the force of attraction between a body of mass m1, and another mass m2, separated by distance r, is given as the force of attraction between two masses. The force of attraction between two masses the force of attraction between two masses is given as F equals G m1 m2 over r squared. I repeat again, from Newton's laws of gravitation, the force of attraction between a body of mass m1 and mass m2 separated by distance r is given by this. Then find the dimension of gravitational constants. Find the dimension of G. This is the force here. This is our what? Gravitational constant. This is the first mass, second mass, the distance of separation, right? So we're looking for the dimension of what? G. What we need to do here is to cross multiply. We have to cross multiply to make our capital letter G to stand alone as the subject of the formula, right? Okay. I have to make this my capital letter G. I'm looking for the dimension of this G. So I'll have to make this as the subject of the formula. So what we do is to cross multiply. So I multiply G m1 m2 by 1. That will give us G m1 m2 all equals to force times r squared is F r squared. The next is, since I want to make my G as the subject of the formula, I will look for a means to eliminate m1 and m2 by dividing both sides by what? By m1, m2, right? Divided by what? m1, m2. So this can go with this. We are left to what now? Our G equals what? Force times square of our radius divided by what? m1, m2. Now the next is to find the dimension of each of these. Dimension of force is capital letter M. Remember, it's L. Okay, let me bring out the units. We have kilogram, right? Meter per second squared. So dimension becomes what? Capital letter M, capital letter L, then T minus 2, right? So dimension of radius squared is simply, which is what? Meter square, right? Radius square simply means radius times radius. So radius has the dimension of what? Unit of in meter. So this will give us what here? L squared. So dimension of mass 1 and what? Mass 2. Okay, let's start with mass 1. Mass 1 is mass is measured in kilogram. That will give us capital letter M. Likewise, dimension of mass 2 is also capital letter M. Now the next is to impute all the values, right? Then our G becomes, our force is ml T minus 2, right? So times L square, our radius square, which is L square, right? Times L square divided by M1 times M2 is simply capital letter M times capital letter what? M. So from here, one of these M can cancel one of this M here, right? Here we have L raised power 1, L raised power 2. Law of indices. When you take one of these L, we have to add up the power. The power of L here is 1, right? Okay. So that will give us what? Our G equals L times L. When you take off, we have one M remaining here. When this M comes up, it becomes M minus 1, right? So L times L times L squared will give us L raised power 3. Exactly? Because from the law of indices, since they have a common base, I'll pick one of the base and add up the power. 1 plus 2 is 3. Then we are left with what? T to the power of minus 2. Final answer. Final answer. What if we are now asked to find the units from the dimension? This is very simple. The unit of G, this is our mass, which is kilogram per kilogram. We have meter cube per second square. The unit of G. Mass is kilogram, length is meter, and time is what? Second. So we are done with this question. The next question. Let's look at some of the applications, how we can solve some problems regarding some of the applications. Okay, this question here says, show that the unit of v square over r are those of acceleration. Show that the units of v square over r are those of acceleration. We want to show that the unit of this are those of acceleration. To show, all you need to do first is that the unit of acceleration, note of acceleration, we know is what already? Meter per second squared. Exactly. Then we are given that we are given v square over what? Over r. We are given v square over r. Okay, now let's go. What we need to do is to the dimension for v square, for v rather, is lt minus 1. All what here? Squared. Don't forget that this v represents speed, right? So dimension for speed is lt minus 1. Then we have square here. I have to square this. Dimension for radius. Radius is measured in meter. So it becomes what? L. And that will give us what? Yeah? Yeah, I can expand this to be L square t minus 2 divided by what? L. Right? One of these L, we cancel one of these L from here. Here we are left with what? LT minus 2, final answer. This is the show. So after the proof, we find out that the result, the unit of this, are those of what? Acceleration. So I can end up by saying capital letter L is meter, our T is what? Per second square. Final answer. So this is how to show that. Next question. The question here says, what do you understand by the dimension of physical quantities? I've already explained that to you. If this should appear in your exam for those who are in Imo State University, the answer here is that it refers to the way it is connected, associated, or related to the fundamental quantities of mass, length, and time. Then now say explain the distinction between fundamental and derived units. Fundamental units are basic units of measurements. These are units that are self-defined, right? They don't depend on other units to define them. In this case, I'm defining this in respect to units. It's almost the same thing with fundamental quantities. Do you understand? The one you hear the word derived units. These are units that are not self-dependent. They depend on fundamental units. Do you get? And they are gotten either by multiplying two or more fundamental units. An example of each of them. Under fundamental units, meter. What I say fundamental units, meter, right? Kilogram and what? And seconds. Or we can say Kelvin. Exactly. The one I say derived units. A good example is the unit of what? Velocity, which is meter per second. Unit of acceleration, meter per second squared. Unit of density, which is kilogram per meter cube, right? Unit of volume. Volume is derived because volume is length times length, which is meter cube. Area is also derived. Pressure is also derived. This is just how to answer this. Then the next question here says, let's look at this question we have here from your textbook. I want us to just one of these, then we'll move into something else. The velocity of a wave in a string of length L, mass m, and under the tension force is given by the velocity of a wave in a string of length L. The velocity of a wave in a string of length. The velocity of a wave in a string of length L, comma, mass m, and under the tension force, and under the tension is a kind of force, right, on the strings, is given by V equals K F raised power X L raised power Y, the M to the power of Z. Then the question says where X, Y, and Z are constant. Where X, Y, and Z are constant, find the value of X, Y, and Z, and also the dimension of K, the value of X, Y, and Z, and the dimension of K. This is very simple. They made this question so simple, so easy, by defining all the terms for us, that V represents the velocity of a wave in a string of length. L here is length of mass M. Our M here is what? Mass. And under the tension, that means our tension F. Our F here is the tension. Tension and force have the same dimension, right? They have the same dimension. So what we need to do is to bring out the dimension of each of these. Dimension of V is LT minus 1. Dimension, by now we know what I'm doing, right? Of force, of tension is the same as force, right? Is actually NLT minus 2. Dimension of length L is capital L. Y dimension of mass is capital letter what? M. Please, if you are following, indicate that you are following. If you are following, please indicate that you are following. If you are following, indicate that you are following. Yeah, good morning. You're welcome. The light. Okay, play Crystal, good morning. Okay. Okay. Favor Amarachi, good morning. You're welcome. Happy new month to every one of you. Please, if you are following, indicate that you are following. All right, so let's continue. Okay, while you are writing, while you are learning, do me a favor, every one of you. I know most students are sleeping by this time. For you guys to be awake, it takes a level of discipline. At some point, when I woke up by 4 a.m., I almost canceled this class. But I said, no, I've already committed myself. I have to be awake. So do me a favor, please share the link now. Go to your WhatsApp groups for different departments. Share the link. Share the link. Just tag people. Tag the general group or tag people. Let them join us in this class. I'm giving every one of you 1 minute to do that. Just 1 minute. Then we'll proceed to this. Okay? We'll proceed to this. Just 1 minute. 1 minute. We have just limited time. Just 1 minute. Okay? 1 minute. 1 minute. Please do so. Do so. Please share. If you have shared it, just let me know you have shared. Let me know you have shared. Let me know you have shared. If you have forwarded, let me know. Let me know. Let me know. Let me know. 1 more minute. 1 minute. 30 more seconds, rather. 30 seconds. Just share. Just share. Indicate if you have shared it. Just tell me, yes, I've shared. Please indicate that you have shared. Oh, let's continue now. Now, the velocity of a wave in a string of length L mass M under the tensional force is given as this. I've listed out the dimension of V, dimension of what? Force, dimension of L, and that of what? Mass. Is that clear? So I hope you guys are back. Now let's proceed. For those of you who are awake. Okay, now look at this now. Is that the dimension of V? I have to impute all their dimensions now to this general expression. Dimension of V, velocity, is LT minus 1 equals dimension of K. K is a constant, is 1. So I won't repeat this K, right? Dimension of force is M LT minus 2, all raised by what? X. Don't forget. Times the dimension of length is capital letter L to the power of Y. Dimension for M is capital letter M to the power of what? Z. I repeat again. We have gotten the dimension of each of these quantities mentioned. Dimension for velocity is LT minus 1. For force is MLT minus 2. For length is capital letter L. For mass is capital letter M. Now the next is to impute their dimensions. That speed is LT minus 1 equals dimension for K. K is a constant here, right? Is 1. Every constant must have dimension of 1. So here, force is simply this to the power of X. Length is this. Mass is this. So the next is to expand this because all of these terms here are affected by these exponents. So let's expand. We have LT minus 1 equals M to the power of X, L to the power of X, then T to the power of minus 2 times X is what? Minus 2X, right? So all times L to the power of Z, then M to the power of what? Z. So we have LT minus 1 is equal to, now we want to take the like terms, like we compare. So we take the like terms, okay, in terms of their base. Look at this now. This M here and this M have a common base, but they have different powers, right? So we'll pick one of these M and add up the power. Okay, so that means here becomes capital letter M. The power here is what? X plus what? Z. From the law of indices, right? Pick one of the base and add up the power. We have done that for that of M. Let's proceed to that of what? Letter L. Letter L, we have L raised by X and L raised by what? Y. So we have L raised by what? S plus what? Y. Okay. The next is we have evaluated this and with this with this. So we are left with what? T to the power of what? Minus 2 what? X. Now the next is to compare both sides. We compare both sides of the equation. We compare both sides of the equation. In comparison, I'm comparing my M to M, my L to L, my T to what? To T. Listen, the metric system says it must be of this order, right? MLT. It must be of this order. But if you look at this part here, we only have LT raised by minus 1. Although we have M here, but the power of that M is what? Is 0. I can decide to put my M here to the power of 0 because I want to compare. I want to compare this side with this side. So what I did was to bring out my M because since I have M here, I have to bring out the same the same base, but the power will be what? 0. Because in indices, any value or any number raised to the power of 0 is equal to what? 1. So even if I put m raised power 0 here, it's the same as what? As 1. And so the whole of this here is same as this. So I've not really altered anything. The reason why I have to bring out this because I want to compare both sides. But I think I have to bring out, we have this, let me just repeat the same thing. Yeah, let's repeat it here. So by comparison, I'll bring out every term we have here should also appear on this side. But the power of m here must be what? 1. Sorry, 0 rather. So here becomes m to the power of 0, lt minus 1, right? Because I want to compare, so I have to bring out all the terms. So here we have equal to, let's repeat this, m to the power of x plus z, m to the power of x plus what? Z. The next is what? L to the power of x plus y, x plus what? Y. The next is t to the power of minus 2x, minus 2 what? X, minus 2x. Now, why comparing? If you look at this, in indices, if I have 2 raised power x equals 2 raised power what? 2. I can compare this because the bases are the same, right? We can cancel out the base because they are the same and increase the power. That means x is equals to what? 2. The same thing will also go with this. Why compare? I'll compare m with m, meaning m to the power of 0 is equals to what? M to the power of what? X plus z, right? Is that clear? That implies that x plus z, since the base are the same, they will cancel out, right? X plus z equals to what? 0. But because of space, let me just go straight to the point. Why compare m with m? I will equate the power, meaning x plus z equals to what? 0. X plus z equals to 0, equation what? 1. Let's compare the value, the power of L. The power here is 1, right? For L. But the power here is what? Is x plus y. So x plus y should be equal to what? 1. Equation what? 2. Let's compare the value of t. The power of t here is what? Minus 2x. But the power of t here is what? Minus 1, right? Minus 1. So that will give us what? Minus 2x is equal to what? Minus 1. Minus 2x equals minus 1. So minus can cancel minus from here. 2x equals to 1. That means to find the value of x, we have 1 over what? 2. Now we can put the value of x. We can say put x equals to what? 1 over 2 in equation what? 1, Abi? Equation 1 that says that x plus z equals to 0. X plus z equals to what? 0. So that means here becomes what? Half plus what? Z equals to what? 0. Therefore, when you evaluate this, when you move this 1 over 2 to the other side, the value of z becomes minus 1 over what? 2. Also, we can also say we have gotten our z, right? So the next is to find the value of what here? Of y. So I can as well put our x equals to 1 over 2 in equation what? Equation 2, right? And that will give us what here? X plus y equals to 1. So we're going to have 1 over 2 plus y equals to what? 1. Is that clear? Okay, equals to 1. So from here, it means that our y equals 1 minus half. The result should be what? Half. When you subtract half from 1, the result will be 1. Therefore, our answer becomes, the value of our x is half, our y is half, but z is -1/2. So take note of this. Take note of this. Now the next one says find the dimension of k. The value there is 1. So is there any need of finding the dimension for k? The value there is 1. Is 1. I hope I can clean this side. Okay, now look at this. Sometimes they might ask you to find the expression. After finding x, y, z, they might tell you to find the expression connecting speed, force, length, and what? Mass. Okay. The answer is, I just recall that our speed is given as k f raised by x, f to the power of y, m to the power of what? Z. Okay, so the next is, so the expression means the formula. We say one of the applications of dimension analysis is that it is used in deriving what? Formulas, right? So we can derive the formula for this. It means what is the formula connecting them? That will give us V equals K. We have force to the power of X is what? Our S is half times L. Our Y is half. M is minus half. Are you there? Minus half. So this will give us V equals K times square root of F. F to the power of half is root of F. This will also give us what? Yeah? L. Root of what? L. Then divided by, because I have 1 minus 1 minus here, it becomes 1 over m, right? To the power of what? Half. Don't forget. It becomes 1 to the power of what? 1 over what? M to the power of half. Exactly. And that will give us 1 divided by what? Square root of what? M. So this expression here is divided by square root of what? Of m. Okay. Now let's move on. So V is equal to, we have K. There's a law of sword. The law of sword that says sword A times sword B. The law says what? Sword what? AB. Meaning multiply A with B. If I have sword 2 times sword what? 3, the result becomes what? Sword what? 6. So I can do the same thing here. Sword F times sword L will give us what? Sword what? FL, right? Divided by what? Sword M. There's another law of division that says sword A over sword what? B is equals to sword what? A over B. So this becomes what? K sword FL divided by what? Mass. So this is the formula connecting speed, right? Force, length, and what? And mass. Then the question says, what is the dimension for K? Since K is a constant, dimension is what? Is 1. That is the answer to that. Since K is a constant, the dimension is what? Is 1. Right? Or we can, from here, make the value of K as our subject of the formula, then find the dimension of each of these. At the end of the day, we end up having what? 1 as the final answer. 1 as the final answer. Right? Okay. If you are following up, just say, I am following. Please indicate that you are following if you are following. We'll come to the end of this morning's class very soon. Then our next class will be by 6 p.m. today, 6 p.m. or 7 p.m. today. All right. This is just to clear this part of physics for those of you who are still having challenge. So a lot of people I found out are still having challenge in this topic. Okay, let's solve this problem from your textbook. Problem says verify the dimensional homogeneity of the equation for total energy at the top of a loop given by mgh equals 2 mgr plus half mgr. Please, if you are following, indicate that you are following. If you are following, please indicate that you are following. If you are following, please indicate that you are following. All right, so let's proceed. Now, I want to verify the homogeneity of this equation. One of the applications of dimensional analysis is to verify the homogeneity of an equation. Now, if I'm to verify that this is homogeneous, that means that all the terms here must have equal what dimension. All the terms must have equal dimension. So solution is that the dimension, let's find the dimension for each term, Sabi, for each terms. For each term. The word homogeneity means homogeneous, meaning the same. So they must have the same dimension. Now for each term, what's the first one there is mgh, right? The dimension here, this is mass, this is our gravity, this is height, Abi. All right. So mgh, dimension for mass is capital letter M. Dimension for gravity. Acceleration due to gravity have the same dimension of acceleration, okay, which is what? LT minus 2. So acceleration due to gravity have the same dimension with acceleration because both of them are what? They are actually acceleration. So they must have the same dimension. So this is times LT minus 2. Then the dimension for height is meter. Is capital letter L, rather. Okay. So dimension here becomes what? M. L times L is what? L squared. Then we have T minus 2. That is for this. So let's look at for 2 mgr. 2 mgr. To find the dimension of this, what do? Dimension for 2 is 1 because 2 is a constant. And every constant must have a dimension of 1, right? So we have 1 times dimension for mass is still capital letter M. That of G is LT minus 2. That of radius is what? Is L. And that will give us what here? We're having L times L is L squared. So ML squared T minus 2. Right? Okay. Now let's verify the last one. Of course, it's the same thing. So for half mgr. Dimension for half is 1. Dimension for mass is capital letter M. For gravity is still, okay, let me use dots, okay, anyone, is still LT minus 2. Then for radius is L. This will give us what? M L squared T minus 2. So how do we conclude? Since all the terms have the same dimension, that means the equation is what? Homogeneous. It's homogeneous. It's the same. All right? Since all the terms in the expression have the same dimension, so that means the equation itself is homogeneous. Okay. That is for that. I'm going to drop an assignment for every one of us to take note of, possibly maybe in the comment section, or let me dictate the assignment. Please take note of this assignment. Take note of this assignment. Assignment number 1. This might be your exam. You might just pick this as one of your questions in the exam. Find, number 1, find the value of x, y, of x and y in the equation for the period of a simple harmonic motion t equals 2 pi m to the power of x, k to the power of what? Y. 2 pi m to the power of x, k to the power of what? Y. This is period, right? All right. Where the unit of mass is in kilogram, where the unit of mass is in kilogram, and that's for the first constant k, and okay, and that for the first constant k is Newton, k is Newton per meter. Newton per meter. Then the answer we are given x. Answer is given as x as half, y as minus half. Okay. We have find the value of x and y in the equation for the period of simple harmonic oscillator. Harmonic oscillator as t equals 2 pi m to the power of x, k to the power of what? Y. Where the unit of mass is in kilogram. Mass has a unit in kilogram, don't forget. And the unit of k is Newton per meter. Unit of k is what? Newton per meter. They call it first constant, right? Which is Newton per meter. Don't forget that k is Newton per watt meter. What does that imply? Meaning Newton over watt meter, which is about force, right? Force over what? Length. Don't forget. It means that k is Newton per meter, which is force over length. So what do we do? Is to find the dimension of what? Of k using force over length. Let me just assist you here so you can easily solve it for me. So force is going to give me ml minus 2 divided by what? Our length is L. So length can cancel length. So the unit dimension for K becomes mt minus 2. Exactly. So what you're going to use to represent K is this. Okay. Dimension for mass is capital letter M. Don't forget. Dimension for 2 pi is 1 because 2 pi is a constant. Okay. So we have to find the value of x and y in the equation for the period of a simple harmonic oscillator. Now, after getting the value of x, y, and z, please also find the expression. Also find the expression connecting all the terms. Find the expression. Find the expression connecting period, mass, and k, first constants. Period, mass, and k. Period, mass, and k. Find the expression. I hope this assignment is clear. Okay, I'm not going to solve it, but I've been able to define something for you that k represents force over length, which is mlt minus 2 divided by length. Length cancel length, so mt minus 2. I hope this is clear, right? If it's clear, please indicate from the comment section that it is clear. If it's clear, please indicate from the comment section. Assignment number 2. Assignment number 2. Assignment number 2. Please, once you are done with the assignment, forward your answer. Forward your answer. If possible, if you can type out some parts and send to the comment section. I would love to see what you did. Okay? I would love to see what you actually saw. Please forward it, type it here. Assignment 2 says, this is very long, but I will turn the text. A body moving through air at a speed v experiences a retarding force given by, the retarding force experience is given by Ka density then v to the power of x. Experiences a retarding force given by this, where A is the surface area of the body. Where A is the surface area of the body, this symbol rho is the density of the air. This is the surface area of the body. This is called the density. Okay, density of the air, and K is numerical constant. K is called constant. K is called constant. Right? K is called constant. Then we have to deduce the value of x. Okay, our v here represents speed, don't forget. But the power of our v is simply x. This is how the equation came. Then continuation from the same question. A sphere of radius 50 millimeter. A sphere of radius 50 millimeter and mass 1 kilogram falling vertically through air of density 1.2 K of density 1.2 kilogram per meter cube falling, okay? I repeat again, a sphere, a sphere of radius 50 millimeter, 50 mm, A sphere of radius 50 millimeter and mass 1 kilogram falling vertically through air of density 1.2 kilogram per meter cube attain a steady velocity of 11 meter per second. Attain a steady velocity of 11 meter per second. Assuming the above equation apply, this equation, assuming the above equation applied, calculate the value of k in this case. Calculate the value of what? K in this case. Find the value of k in this case. The first question said find x, right? Find x. Number 2 said find what the value of k. Let me repeat my dictation again. The question says a body moving through air at a high speed, v, experiences a retarding force given by this. This is the retarding force given by this, right? Now we are told that where A is the surface area of the body, rho, this symbol, is the density of the air, and K is the numerical constant. Okay? K is what? Numerical constant. Deduce or find the value of x. That was the first question. Find the value of x. Number 2 says a sphere, okay, a sphere of radius 50 millimeters. So a sphere is spelled as SP, right? SP. Sorry for that mistake. A sphere of radius 50 millimeter and mass 1 kilogram falling vertically through air of density 1.2 kilogram per meter cube attain a steady speed of 11 meter per second or a steady velocity of 11 meter per second. Assuming the above equations apply, which is this, we are asked to calculate the value of k in this case. Find the value of k in this case. So please, I won't give you the answer to this. Any answer after solving, put your answer in the comment section. So we'll meet again by what time today? By 6 p.m. or by 7 p.m. Please take note. Make sure you subscribe to this channel. So that once we are online, it will just pop up. But the challenge is that most of us have not really subscribed and we are attending this class. Make sure you subscribe. Subscription will help you to get notifications on time. Once we are live, it will just pop up. And please ensure you share this link to other people. Imagine what we are learning. And all of these things we appear in your exam. What we are doing here is exam focus examination preparation class. I'm just trying to focus on the exam. What are the things that you'll be expecting in the exam? These are the things you'll be expecting in your exam. All right. So please, because this class will not always continue. A time will come where I have to stop for a while. Okay, for you guys to study and all that. So please, we meet again by 6 p.m. Still on physics, intensive class in physics. Then on Saturday, our class will be so intensive because we're having like almost 5 hours stretch at a time. 5 hours stretch at a time. So please, let's just take note of this. So far, we have learned. So see you guys tonight by 6 p.m. Once again, happy new month to every one of you. Thank you so much. My name remains EMI-BRAIN. For those of you that would like to reach out to us, this is my WhatsApp contact 09063111961. This is my WhatsApp contact, okay? My WhatsApp contact. If you want to reach out to me, maybe to join our WhatsApp group, or if you have any question, or after solving the assignment, if you can send your answer rather on my WhatsApp platform. The ones you solve, just snap them and send to me. Let me verify what you have done. All right. Then also make sure you send in your solution in the comment section. So see you guys tonight by 6 p.m. My name remains EMI-BRAIN. EMI-BRAIN. This is my name, so you can save my contact. It's EMI-BRAIN. Thank you guys. So love you guys.